Hi guys. So today I'm going to show you guys the 3-3 lesson, which is the chain rule and the general power rule. Okay, so it starts off here with the general power rule. It is used to differentiate a function of x that has a quantity that is raised to a power. Okay, so kind of like if you take a look at example 1, you have a quantity that's raised to a power. So that's a scenario where you'd want to use the chain rule. So to do that, what you're going to do is you're going to derive the outside. So you can see this piece right here looks very familiar. That's the basic power rule. The only additional part to this is that then you multiply by the derivative of the outside. Okay, so we are going to refer to the derivative of the outside as the hook-on factor. Okay, so multiply or find the derivative of the outside, and then we're going to multiply and find the derivative of the inside. Okay, so let's just kind of do that with question number 1. Okay, so if we find its derivative, okay, imagine that this just said x squared. So if I was going to find the derivative of x squared, that would just be 2x. Let's say 2. But since my x piece is a quantity, I keep it as a quantity. And that now becomes to the first power, which I don't need to write. Okay, and then I'm going to multiply by my hook-on factor, okay, which is simply the derivative of the inside. So the derivative now of the inside is 2x. Okay, so that is completely deriving the function of f of x. So at this point, I would want to kind of simplify this and make it look a little simpler. So I'm going to multiply, if I have 2 and 2x, that's 4x. I'm going to distribute 4x through this quantity. So 4x times the quantity of x squared minus 3 is going to end up giving me 4x cubed minus 12x. Okay, so that would be the simplified version of that derivative. Okay, moving to question number 2. Now they write this as a square root. Okay, so the first thing that you have to do on question number 2 is you must rewrite it. You can't write it as a radical. So the rewrite of g of x would be 2x squared minus x to the 3 halves. Okay, so remember the denominator becomes the radical, the exponent stays in the top. Okay, so now we're going to derive this. So we're going to multiply by the outside. So we got x to the 3 halves. So that would become 3 halves times its quantity. And then subtract 1 from the exponent. So 3 halves minus 1 is 1 half. And then we multiply by the hook-on factor, which is the derivative of the inside. So if we multiply, the derivative of 2x squared is 4x minus 1. Okay, to simplify that, you never want to do anything that has a quantity or a exponent. Even if it was squared and it was factorable, you just don't touch it. When you simplify, you're just going to do anything that has a linear quantity and any kind of constant in the front. Okay, so we are going to multiply 3 halves times 4x. So 3 halves times 4 would be 6, so 6x. And 3 halves times 1 is minus 3 halves. And then we're going to leave that quantity to the 1 half alone. Okay, so that would be a simplified form of this function. Okay, so number 3 now, this one is a little bit more complicated because basically what we have is kind of two pieces that are being multiplied. If I rewrite this, we have 3x squared, which is kind of like one quantity, and then it's multiplied by this 9 minus 4x squared to the 1/3 power. Okay, so if I have two quantities being multiplied together, what rule must I use in order to derive those? Okay, so I must use the product rule. Okay, so in deriving this, what's going to end up happening is I'm going to have to use two rules at once. I'm going to start by doing the product rule, and when I have to go to derive this piece that has the exponent, I will have to use the general power rule. Okay, so the product rule goes first d second plus second d first. Okay, so I'm going to go first, 3x squared, d second. So I'm deriving the second piece, which is the chain rule, 1/3 times the inside. And 1/3 minus 1 is negative 2/3. And I have to multiply by the hook-on factor of the inside. So the derivative of the inside would be negative 8x. Okay, so that's the derivative of the second piece. Okay, so moving through the product rule, then I say plus the second, which I just write as is, d first. And when I derive the first piece, the 3x squared, that gives you 9x. Okay, so that is officially the derivative of my f function. I want to write this a little bit nicer so it doesn't look so yucky. I see a 3 times a 1/3, so these two are going to cancel out. I have an x squared times a negative x. And notice this quantity has a negative exponent, which means it's going to go into the denominator. So I'm going to have negative 8x cubed on the top. My quantity with the negative exponent is going to get moved downstairs and then become positive. Okay. On the second term, nothing can be simplified. So I'm going to leave it that way. I'm just going to put the 9x in front because that looks more, it's more typically written that way. And leave it to the 1/3 power. So that is as far as you would want to simplify that. Okay, and you could double check that with your TI Inspire, and it would look something similar to that. It would be close. What they would probably try to do is reorder your denominator and do x squared first, and they might even pull out a negative, which will make it look a little bit different. Okay, so you can always check your answers with your TI Inspire. You want to be able to do this by hand, though. Okay, now the chain rule is used to differentiate a composite function, so a fog or a GOF, so something that is slightly more complicated, something that's been plugged into a different function. Okay, so this is kind of an interesting example. So they give us all this information, and we're going to use these little pieces in order to do this piece right here. Okay, so to do that, I'm going to start by writing what the definition is. Okay, so it is typically, I mean, it really is exactly the same as the one before. Okay, the general power rule, it just is written in terms of f of x and g of x. Okay, up above we had a u, which was going to be our g of x as down below. Okay, so those are really the same. So we have the derivative of f of x of g of x times the g of x. Okay, so we're doing this question over here with the p and the q. The derivative of this, so the d dx, is going to equal, and let me write that all out so I have correct symbolism, is going to equal the p derivative of q of x times the derivative of the inside. Okay, so then if you add in that we are doing this in terms of 2 rather than in terms of x, it's going to look like the p derivative of q of 2 times the q derivative of 2. Okay, so if we use our values up here above, we're going to start by plugging in the p or the q of 2. So if you look above, q of 2 right here is actually the value of 3. So I can say of 3, so this piece becomes 3. We'll just do that one step first. Okay, now it has the derivative of p of 3. So if you look up above, now I'm looking at the derivative of p of 3 right here. So that is equal to 4. So this piece now becomes 4. Okay, and I'm going to multiply times the q derivative of 2. So if you find the q derivative of 2 up here, q derivative of 2 is equal to 2. So this basically turns into 4 times 2, which is 8. Okay, so that's kind of a cool little way to do the chain rule. And you will see that type of question on the AP test. They do that kind of thing a lot. Okay, so what I would like for you guys to do as your homework, So you should have this done by the time you come to classes. I would like you to do just 1 through 4 here. Okay, so 1, 2, 3, and 4.